In today's lesson, we will be analyzing graphs of functions, determining relative minimums and maximums, looking at a library of functions, and graphing piecewise functions. The graph of a function is a collection of ordered pairs, x, f of x, such that x is in the domain and y is the range of the function. Let's take a look at this graph. Find the domain and range. We can see the domain starts with the lowest x value at -4 and ends with the highest x value at 6. We can see the range starts with the lowest y value at -2 and ends with the highest y value of 3. The closed dot indicates where x is a value in the domain, and open dots indicate where an x value is not in the domain. To determine a function based on its graph, we use the vertical line test. If the vertical line intersects the graph only once, it's a function. If the vertical line intersects the graph more than one point, it's not a function. So zeros of a function are x values at which f of x is equal to 0, which are otherwise known as x-intercepts. For example, we can see that f of x is equal to x squared minus, or square root of x squared minus 4. And we can see the zeros of this function by setting this whole thing equal to 0 and finding out that x is equal to 2 and -2. Increasing and decreasing functions. Graphs are always read from left to right, and a function is increasing if f of x1 is less than f of x2, decreasing if f of x1 is greater than f of x2, and constant if f of x1 is equal to f of x2. You can see in the pink interval, f of x1 is less than f of x2. We can see in the yellow interval, that f of x1 is greater than f of x2. We can see in the green interval that f of x1 is equal to f of x2, and we can see in the blue interval that f of x1 is less than f of x2. Even and odd functions. An even function has symmetry in respect of the y-axis and is determined when plugging -x into f of x, giving a result equal to f of x. An odd function with symmetry in respect to the origin is determined when plugging -x into f of x to give a result of -f of x. So in this example, we can see that this is the function x squared minus 5, and we plug in -x to see whether it's even or odd. And because it returned the same thing as f of x, we can say that's even. Okay, minimums and maximums. Relative minimums and maximums are determined based on the increasing and decreasing and constant behavior of the graph. Relative maximums are determined when there is no larger y value nearby, and relative minimums are determined when there is no smaller y value nearby. We can see that the red values represent minimums and the blue values represent maximums. So here are some functions that you should be familiar with. These will be very helpful when you learn transformations. Some of the most important functions here are the quadratic function, the identity function, the square root function, the absolute value function. So now let's graph a piecewise function. Piecewise function has two or more equations over a specific domain. The domain is from -infinity to +infinity, but in two different parts of this, it behaves two different ways. So we can see that when x is less than or equal to 1, f of x is equal to 2x plus 3. So this is the graph of 2x plus 3 in green, which ends when x is equal to 1. And we can see that f of x is equal to -x plus 4 when x is greater than 1. So for all the values that x is greater than 1, the graph is now -x plus 4. And we can see that a value of x when it's equal to 1 is on the graph 2x plus 3 and not on -x plus 4, which is represented by the closed dot and the open dot. Alright, so in This video, we reviewed the graph of a function, we reviewed the zeros of a function, we reviewed even and odd functions and how to find them, we reviewed minimums and maximums, and we went over some parent functions that will be manipulated with later, and we went over how to graph a piecewise function. Thanks for watching. See you next time.